Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 17, 2025, about 3 days ago. It delivers standout gains, beating QN 2.5 Omni by plus 19.05 on Daily Omni, plus 1.7 on MMAR Audio, and plus 3.9 on Video MME, while training on just 0.2 trillion tokens, a 6 times reduction versus QN 2.5 Omni's 1.2 trillion. The paper is titled OmniVinci, Enhancing Architecture and Data for Omni-Modal Understanding LLM, and as we will see later, the efficiency and accuracy trade-off is striking. In short, this paper blends 3 alignment and timing innovations with a 24 million sample curated and synthesized dataset to show that vision, audio, and text reinforce one another for stronger perception and reasoning. Also, the authors shared a GitHub repo. You'll find the OmniVinci code with ready-to-run transformers inference, environment setup.sh, and mini examples for audio, image, and video. There's an example infer.py, config via PyProject, assets, and a technical report PDF. Scripts show how to load the model and run multimodal prompts end-to-end. Figure 1 highlights the headline result. The model leads across Omni-Modal, audio, and vision benchmarks. Omni-Modal means combining multiple senses, so the bars compare joint video and audio understanding. On Daily Omni, the purple bar jumps by about 19 points versus QN 2.5 Omni. On the audio set MMAR, the gain is roughly 2 points. For Video MME, the margin is about 4 points, which signals broad strength rather than a niche win. Figure 2 shows how the system fuses vision, audio, and text into one token sequence so the model can reason across time. The top row encodes images, video frames, and sounds, then compresses them into shared embeddings. The middle row aligns modalities using OmniAlignNet with a contrastive loss, which means paired audio and video are pulled closer in the embedding space. Temporal embedding grouping and constrained rotary time embedding inject relative and absolute timing. The right side routes the unified tokens into the language model to produce text or speech. Well, Figure 4 shows how the data engine fixes cross-modal mistakes, so captions reflect what the video and audio jointly convey. Modality-specific hallucination means a caption from only vision or only audio invents details because it lacks the other sense. The top row presents separate vision and audio captions for short clips, which disagree and drift from the truth. The green block below is the corrected Omni caption produced by a language model that fuses both streams. So Table 1 reports how each added component changes accuracy across the 3 Omni benchmarks. Temporal embedding grouping, which groups tokens into ordered time chunks so timing is explicit, lifts the average by about 2 points. Constrained rotary time embedding, which encodes absolute timestamps with bounded rotations, brings the average to about 50. OmniAlignNet, which pulls audio and vision closer in a shared space, raises the average to about 53 and delivers the strongest Omni bench jump. The consistent pattern shows that temporal structure and cross-modal alignment both matter. So Table 3 shows the headline comparison. OmniVinci delivers the highest average across Omni benchmarks. The average reaches about 54, which exceeds QN 2.5 Omni. On WorldSense, the score is roughly 48, and on Daily Omni it rises to about 67. OmniBench lands near 46, which is competitive with closed systems because the model unifies audio and vision effectively. Alright. 2 takeaways stand out: aligning and timing tricks, namely OmniAlignNet, temporal embedding grouping, and constrained rotary time embedding, plus a 24 million sample data engine, unlock stronger cross-modal reasoning with only 0.2 trillion tokens. The broader implication is practical omni-modal AI for robotics, medicine, and industry. That is it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.